already heard before, but I will try to present in a systematic way the ESA Earth Observation Program, and in the end also some tools that will be developed for education, for universities, and for schools that you can use. So, as you probably have read in the last months or last year, there were many new items of interest for the general public, which were possible to study and to detect from the satellites, like the earthquake in Haiti, which was damaged. The damage were met by use of satellite data. Of course, the differences in the ice shelf, which has been detected in the last years by satellites, and the launch of Cryosat, which is a satellite dedicated to measuring the ice thickness, and the oil spill in the Gulf of Mexico, which were caused by BP, and which were also measured by satellite data. And as you remember, probably most of you who needed to fly last year, the problem of the volcanic eruption in Iceland, which caused a heavy impact from the aircraft navigation. So all these things nowadays are possible to measure by satellite images, and not only for science, for study, but also for operational life. The ESA program started with Meteosat, so for meteorology, in the 70s, and after a few years this program became also an operational system, where nowadays all data used by meteorologists, or most data used by meteorologists for forecast and for monitoring, are derived from satellite data. The same is happening with Earth observation, because satellites which were launched in the 80s and in the 90s for experiments and for science are now becoming a means of operational monitoring of the planet, and especially with the GMS, which has been explained before, we will be able to provide a continuity of data for services which will be completely operational based on the integration of satellite data with the in situ data. The ESA Earth Observation program is based on, let's say, two major components. So there is a science component with Earth Explorers, which have been launched now, the first three since a couple of years, and we will continue with other satellites, which are scientific satellites, not operational satellites, but which are supposed to provide answers to scientific questions, and an operational segment, space segment, which is the Sentinels, to be launched from 2012 on, to provide continuity of data which are now provided by satellites like Spot, ERS, ESA, and so on, Landsat, which will not be able to provide a continuity otherwise without the Sentinels. We have now presently 6 missions in space, European missions in space, ESA, and with the most scientific projects which are based on ENVISAT data. ENVISAT is the largest Earth observation satellite ever launched in 2002, and a huge number of data which are acquired continuously from these missions. And on top of ESA missions, we also provide data through partner missions, so third-party missions like ALOS and many others, Spot and so on, which can be also acquired through ESA by the scientific community. So ERS-2 and ERS-1, they were launched respectively, so 1991 ERS-2 and ERS-1 and ERS-2, which is a twin satellite with small differences. 5 years later, for a few years they have been operated in a tandem configuration, providing data for interferometry, pairs for interferometry, at that time were one of the best means to generate acceleration models. And ES2, which was designed for 3 years lifetime, is So this measurement compared with the ice extent, which is possible, for example, by means of radar data, allow to improve very much the knowledge that we have about the ice in the polar regions and their variations by combining thickness and the extent. So all these type of measurements are very important not only for science, as I say, but also for the impact that they have on life on Earth and also on economy. For example, in the case of the change in Arctic, the Arctic is a region which has a high relevance for transportation, of course for climate, for tourism, for many other, for oil and gas, which of course has a very high economic value. And unfortunately, the trend in the ice extent measured in the last years it is much worse than what has been foreseen in the past by means of models. If you look at the red curve, this is the measurement in the ice extent which has been detected by space compared to the forecast from the models. The changing oceans, we talked about that before. This is the trend in the global sea, green sea level, and this has, of course, an impact on countries like Bangladesh, which are very low, and this have an impact on wars and economy, also on neighboring countries. Atmosphere, changing air quality. So by means of sunlight measurements, it's possible to measure with the, let's say, well, theoretically with a daily, but in practice with a monthly or weekly frequency, the concentration of gases like NO2, which is an index of industrial activity, and you can see by yourselves the concentration measured on Europe, on the west part of the east part of the United States, but especially since 5 or 6 years over China, which is now the main source of production of this gas in the atmosphere. For disaster management, it is possible to use radar data to measure the presence and the distribution of oil spills in the ocean, and this can be compared and integrated with models showing the currents in the ocean circulation in order to forecast the extension and the direction of propagation of these oil spills. The Louisiana oil spill. And ESA also started now a new program which is called the ESA Climate Change Initiative for the exploitation of the huge archive of data which are relevant to the study of climate change, and to provide a number of essential climate variables which are then provided to the scientific community in order to study the climate change phenomenon. So this is done in cooperation with other entities, with UNESCOR and the European Union, and this is a forecast not done by ESA, by the scientific community, about the situation in terms of temperature which could be affecting Europe in 2071. The climate variables are related to physical parameters which can be related to the climate change, and which can be measured by means of the archive data provided by ESA and by the partner agencies. So they are related to the atmosphere, ocean, and terrestrial, and they concern clouds, carbon dioxide, systems of temperature, of course, glaciers, and so on. The GMES program, which has been measured before, is an initiative, joint initiative of ESA and the European Union to provide independence of data sources to Europe for the environmental and security monitoring, and this is done also by means of a space component which is developed by ESA, which is